Okay, now your week 2 module was about electric potential and work. Okay, now in kinematics, this is your the same thing. Ito yung formula for work. Work equals force times the change in displacement. So F delta D. Now, when we speak of charges, so there is actually work done to move the charge from point A to point B. So for example, this is the charge here. Okay, that's the charge. For example, you can actually move this. Let's say this is your point A of charge 1. Let's say this is Q. Okay, Q1. So you can actually move this charge to another point. So for example, you can move that to point B. Okay, so there is actually a work done by Q when you move this from point to another point. So the work done is solved by this formula F delta D, where W is the work done on the charge, and then F here is the force and the displacement D from point A to point B. Now, if you again replace here F with the electric force K Q1 Q2 over R square, so ang mangyayari is you will have a new formula for work, which is this already. Work is equal to K times the quantity of Q1 Q2 over R2, so you have 2 points already kasi. Then minus K times the quantity of Q1 Q2 over R1. So notice that you already have 2 points. This is the first point R1 here, and then yung after siya na move, ano yung kanyang location na or displacement. Okay, then that's R2. So this will be your formula. So let's have an example to that, okay, later. Now, for electric potential naman, sometimes electric potential is also called as the electric field potential, or the potential drop, or the electrostatic potential, and it is defined as the amount of work energy. So the amount of work energy needed to move a unit of electric charge from a reference point to the specific point in an electric field. So for example, you have two charge. Let's say this is Q1. Then you have Q2, for example. Ay, ang laki naman. Ang laki naman ang pagkalagay ko sa Q2. So for example, this is Q2, okay? So this is your first charge, Q1. For example, they are both positive charge. This is also positive. Okay? So there is an amount of work energy that is done on Q2 by Q1 here. For example, this is your point A. Tapos, as you see, they're both positively charged particles. So, for example, pareha sila na positive. So, there will be a, what type of force do you think? Electric force. There's actually a repulsion of forces, diba? Opposites attract, and then same charges repel. So parang magre-repel sila. The Q2 here will move a certain distance. So ito pa rin yung Q2, but nandito na yung point B niya. Okay? Kasi na-move siya. Okay? So, meron kang distance dito, and then you will also have this distance dito din. There's a repulsive force, so na-move siya palayo, okay, sa Q1. So, you have here a new location, okay? So, let's have more examples, okay, later. Okay, your electric potential, ang formula naman nito is V. Ay, ba't ang laki? So, V here equals V K, which is still your columns constant, and then Q over R. Then the unit for your electric potential is capital V, which stands for volt. Okay, then later you will know that this electric potential may sometimes also be called as your voltage. Okay, and you have volt as the unit, volt. Now, in all our calculations or in all our solutions, we have to really express units in their standard units. So, kailangan kino-convert na lang talaga natin if we see micro, nano, yung small n. So, that's -9. Micro stands for -6. So, we really have to use those what we call this prefixes ng mga notion ng ating scientific notation, okay? So, makikita din sa mga examples natin, we always use microcoulomb, nanometer, or nm. Ito yung mga units natin that are very, very small. So, for example, nanometer, that's 10 raised to 9 meters. Okay? So, sobrang liit. So, -9 ang kanyang exponent for scientific notation, and if it's micro, it's -6. So we have always to pay attention with that. So let's have some examples.
So here is the sample problem for work done. The problem is the charge Q -6 nanocoulomb affected and moves by the other charge Q1 this is +6 nanocoulomb from point A of 9 nanometers to 4.5 nanometers. What is the work done by the Q on Q1? So take note, you have two charges here. Okay, -6 nanocoulomb and +6. So for example, nandito yung Q, and this is your Q1. This is negative, this is positive, right? Then from point A, this is your point A here, because this is attractive force, negative and positive, right? So from point A, na-move siya papunta dito. This is still your Q1, but the distance already is 4.5 nanometer from here. So, originally, ito yung kanyang distance. This is 9 nanometer. So, ganito siya. So, remember, our formula for work is Q1, Q2 over R2 minus Q1, Q2 over R1. So, this is our formula. Okay. So, our given, by the way, so isulat na natin first ang constant natin because kailangan natin ng constant dito. So, your constant is 9 times 10 to the 9 Newton meter square per coulomb square. Q1, that is still equivalent to Q1 and Q2. Okay. So, meron kang -6 and +6 nanocoulomb. Nanocoulomb, so -9 yan siya. -6 times 10 to the -9 coulomb. This is +6 times 10 to the 9 -9 coulomb. So, ganyan yan siya. Then, what else do we need? Meron kang K, dalawang Q, and the R. Yung R1 mo na original is 9 nanometer. And your 9 nanometer is 9 times 10 to the -9 meter. Your R2 is 4.5 nanometer or 4.5 times 10 to the negative 9 meters. So, kumpleto ang given natin. Ilagay natin siya dito sa ating formula. I already have inputted all the given. Okay, so our K constant here, 9 times 10 to the 9 Newton meter square per column square times our Q1 and Q2, which are the same value, 6 by 10 to the negative 9 column. The other one here is negatively charged and the other one is positively charged. So, okay lang yan kapag i-multiply mo siya, the charge, the negative sign, kahit hindi mo na yan siya i-include because that will only identify or indicate that the charge is negative. And with this, malalaman natin kapag negative ang isang charge and positive yung isa, then may attraction, okay, na electric force. But continue lang tayo dito sa pag-multiply and then divided by our R2, which is 4.5 times 10 to the negative 9 meters kasi nanometer yan kanina, nanometer. Then minus our K1, KQ1, Q2 over R1. So yung R1 natin is 9 by 10 to the negative 9. Okay, so you just manipulate this, multiply all divided by the 4.5. So ito lahat 9 times 10 to the 9 times 6 by 10 to the negative 9, 6 times 10 to the negative 9. This is 3.24 times 10 to the negative 7 Newton meter square. Okay, kasi na-cancel na dito ang column. And then divided by 4.5, that's 72 Newton meter. Then sa kabila, 36 Newton meter. So, the answer here, 72 minus 36 Newton meter is 36 Newton meter or 36 joule or J joule. That's the unit, standard unit for work. Now, this is the formula, but you can also use another formula kapag iba yung given, okay? Let's go back. Our formula for work is F, di ba ganito siya, force times the change in distance or displacement. So, remember, we can also use our force galing doon sa electric field. Kapag given ang electric field, pwede natin gamitin yun, yung F over Q. So, from here, we can see that ang F natin is E times Q when you cross multiply. So, you can have here E, Q, delta D. So, you can also use this work formula. This is electric field times the charge times the change in displacement. So, again, you will use this. Depende sa given ha. Kapag nakita kayo ng given ay electric field, then we can use this formula. Electric field, charge, and distance. But if given ang charge at ang R or ang distance, then ito ang gamitin natin na formula.